A new approach to producing metamaterials draws on Kirigami techniques to make three-dimensional reconfigurable building blocks that can be used to create complex dynamic structures. Because the design approach is modular, these structures are easy to both assemble and disassemble. The researcher says that applying Kirigami to three-dimensional materials offers a new level of reconfigurability for these structures. Researchers are optimistic that these 3D metamaterials could be used in applications such as lightweight construction materials for buildings, components for modular robotics, and waveguiding in acoustic metamaterials. Kirigami is a variation of origami that involves cutting paper in addition to folding it. While Kirigami is done using two-dimensional materials such as paper, the researchers have applied the principles of Kirigami to three-dimensional materials that are cut into connected cubes. Specifically, the researchers modeled their new approach using a series of 8 connected cardboard cubes that are open on two sides. Think of each unit of 8 connected cubes as a building block. Depending on how the cubes are connected to each other, these building blocks can be folded into more than 300,000 different designs. Think of these Kirigami units as versatile building blocks that can be assembled to create larger structures with different mechanical properties. What is more, the larger structures can also be disassembled, allowing users to reassemble the Kirigami units into new structures. To demonstrate the utility of the concept, the researchers created more than a dozen reconfigurable building blocks. Each block consisted of 8 connected paper cubes and could be reconfigured into 8 different shapes. Depending on the orientation of the solid cube walls and open sides in each block, the placement of each block in the larger structure, the structure will behave differently. This allows users to tune each building block's mechanical properties. For example, a single building block could be folded into a structure that can be easily compressed or refolded into a different shape that is capable of bearing a significant load. The paper 3D transformable modular Kirigami based programmable metamaterials is published in the journal Advanced Functional Materials.